The second question. Given that this expression here will be equal to a root b, find the values of a and b, 3 marks. Let's consider the solution. So you can assume that we are dealing with fractions here. So there's a fraction here to subtract another fraction here. And therefore, the first step that we normally consider is the LCM of the denominators. And for this case, to consider the LCM, we can decide to multiply the denominators, which will lead us to difference of two squares, and it will help us to rationalize the denominator. So we'll end up saying here that our denominator will be 3 root 2 to subtract 2 root 3. Now we are supposed to multiply by 3 root 2 plus 2 root 3, which will end up leading us to 3 root 2 squared to subtract 2 root 3 squared. This is difference of two squares, whose solution can lead us to that is 3 squared, that is 9 times root 2 squared, that is 2, which will be 18. And here this is 2 squared, which is 4, multiplied by root 3 squared, which is 3. So you're going to subtract here 12. And then if this is the LCM of these two fractions, we normally say that we consider the LCM and then we divide by this expression, and the solution we get will be multiplied by the numerator here. So for this case, when you take these two expressions and you divide by this expression, you're going to be left with this expression here, which will multiply root 3. So on the numerator side, we end up having root 3 to multiply 3 root 2 plus 2 root 3. And then when you take again this expression and you divide by the denominator in this fraction here, you're going to be left with this expression here, which will now multiply with this root 2. So you're going to end up having here subtract root 2 to multiply 3 root 2 minus 2 root 3. And then the next step is for us to open the brackets. We are going to consider root 3 multiplied by 3 multiplied by root 2. This will simply be 3 root 6. And then root 3 multiplied by 2 multiplied by root 3. You're going to see here that you're having root 3 to multiply itself, which will be 3. To multiply 2, you end up having positive 6. And then on this other side, you're going to have root 2 multiplied by root 2, that is 2. And then times 3, that will be 6, which is a negative number. And the negative times negative here will be positive, and therefore we'll have root 2 to multiply by 2 and then multiplied by root 3. You end up having your answer as positive 2 root 6. And then we can solve by considering putting like terms together. We are going to have these surds of the same order, that is 3 root 6 to add 2 root 6. We are going to end up having 5 root 6. Since we are going to add the coefficients of the surds. And then here positive 6 to subtract 6, that will simply be 0. And therefore our final answer will be 5 root 6 divided by 18 minus 12, which is simply 6. And this is the solution. So if you find that method to be a bit difficult, you can also consider rationalizing the denominator of each fraction separately. For instance, if I'm to consider root 3 divided by 3 root 2 to subtract 2 root 3, I can deal with this one separately by considering its conjugate, and I'm going to have here the fact that the conjugate of the denominator here will simply be 3 root 2 plus 2 root 3, and whatever I multiply on the denominator I also multiply on the numerator. So I'm going to have 3 root 2 to add 2 root 3 on the numerator, and therefore the denominator here is simply difference of two squares, so we'll end up having 3 root 2 squared to subtract 2 root 3 squared, which will simply be 3 squared, that is 9, and then root 2 squared, which is 2, so that will lead us to 18, and then 2 squared, that is 4, and root 3 squared is 3, so you're going to have minus 12, which is what I had on this other side. And then on the numerator side we can open the brackets, which is simply what is here, so we'll end up having 3 multiplied by, or maybe let me write it again, or the solution will simply be, let me cancel this one out, 3 multiplied by 3 root 2, that will be 3 root 6, and then plus root 3 multiplied by 2 root 3, that will be 2 times 3, which is simply 6. And then for the other expression I can have the negative sign here, so that I consider the other fraction, which is root 2 divided by 3 root 2 plus 2 root 3. So again we can consider the conjugate here, which will be 3 root 2 to subtract 2 root 3, and whatever I multiply on the denominator I also multiply on the numerator, so you're going to have 3 root 2 to subtract 2 root 3, and therefore the solution here, it will be, so you're going to consider subtraction. So with this subtraction I can be in a position to effect it on the right side of this expression. That means it should affect everything on the numerator, so I can decide to consider it by saying negative root 2 to multiply this one. The solution will simply be negative, so I'll have 2 squared, that is 2 times 3, which is 6, and then negative times negative here will be positive, so we'll have 2 multiplied by root 2 multiplied by root 3, we end up with the negative, that is negative 2 root 6. And then on the denominator side we'll end up having similar expressions here, because you're considering difference of two squares, so it will simply be 3 root 2 squared to subtract 2 root 3 squared, which will simply be 18 to subtract 12, and on the numerator side here we are going to have negative 6 minus 2 root 6, and here we are going to have 3 root 6 plus 6. Okay, and then since the denominators are common, which is simply 18 minus 12, which is 6, and since I've taken care of the negative sign already, I can decide to write everything on the numerator side, which is 3 root 6 plus 6 to subtract 6, and then to subtract again 2 root 6. Here it was supposed to be addition, I'm sorry, because negative times negative is positive, and therefore it will affect this term here and also here. So whatever I have here is simply what I had previously here. So I'll be in a position to simplify by considering the surds first, which is 3 root 6 to add 2 root 6, which will simply be 5 root 6, and then positive 6 to subtract 6 will simply be 0, and then this will be over 6, and this is the solution. Number 3, simplify this expression here. then give your answer in the form A root B. 3 marks. Solution. So here we can begin by finding the LCM of the denominator, which in our case it will mean we are going to multiply these two expressions, which will lead us to getting difference of two squares. And in other words, it's like we are finding the LCM of the denominator as far as subtraction of fractions is concerned. And therefore, when you divide this multiplication here, the LCM by the denominator of the first fraction, we will be left with root 5 plus root 3, which will multiply with 15. So we end up having here root 15 to multiply root 5 plus root 3, and then subtract, and then when you take the LCM again and we divide with this denominator here, we will be left with this other expression, which will multiply with this 15. So we end up having again 15 into root 5 minus root 3. And then we open the bracket for the next step. We end up having root 15 times root 5, that is root 75, plus root 15 times root 3, that is root 45, and then root 15 times root 5, that is root 45 again, no, root 75, because 15 times 5 is 75, and then root 15 times root 5 here, it will be root 45, but negative times negative is positive, so positive root 45. And this will be divided by difference of two squares. So we're going to take the first term here squared, which is root 5 squared, to subtract the second term, or the B term, which is root 3, so it will be root 3 squared. And therefore on the denominator side we end up having, this will be 5 minus 3, which is simply 2. And then on the numerator side you're going to have root 75 to subtract root 75, which will end up giving us 0, and then we are left with root 45 to add root 45. And since these are surds that are of the same order, we are going to add the coefficients, so we end up having 2 root 45. And for this case, the 2 on the denominator can cancel with the 2 on the numerator, so we end up having our answer as root 45. Now, as far as simplification is concerned, we cannot leave our answer like this. And remember, we are told to have it in the form A root B. So we consider the simplification of the surd 45 by using prime factorization method for the number 45. So we can begin by dividing by 3 to get 15, and then by 3 again to get 5, and then by 5 to get 1. So in other words, root 45 can also be written as root 3 multiplied by root 3 and then multiplied by root 5. So when you take root 3 and you multiply it by itself, you end up having 3 and then times root 5. So our solution is 3 root 5, which is in the form A root B. So if you find it difficult to do it this way, you can consider the other way, where you consider rationalizing the denominator of each fraction separately before you combine them later. So I can consider the first fraction, which is here. So I can write it here, that is root 15 divided by root 5 minus root 3. So straight away in this fraction here, I can consider the conjugate of the denominator, which will simply be root 5 plus root 3. And whatever I multiply on the denominator, I should also multiply on the numerator. So I end up having root 5 and root 3 there. And then the other fraction, I can subtract it here, which is root 15 divided by root 5 plus root 3. The conjugate of the denominator here is simply root 5 minus root 3. And whatever I multiply on the denominator, I should also multiply on the numerator. So I end up having that. So remember, the concept of the denominator here is to consider finding difference of two squares. And so the solution that I'm going to get here will simply be the solution that I found here. So this will help you to know what to multiply on each numerator of the fraction. For instance, it's very hard maybe for a student to know how to consider that this will be addition here and this other one will be subtraction by the method of LCM. But then if you do it this way, it will be easier to come up with the solution, because the denominators here will be common. And the moment you have common denominators, then you focus on the numerator. So on the numerator side, we end up having, we open the brackets, you're having root 75 plus root 45, and then to subtract, I can decide to deal with whatever is on the right side of the negative first, which will be root 75 minus root 45, and this will be divided by difference of two squares. I can capture it here, root 5 squared minus root 3 squared, and also I can consider here root 5 squared minus root 3 squared. And therefore, if I'm to take care of the negative sign, since I know the denominator will be common, which will simply be 2, I'm going to have root 75 plus root 45, and then the negative should affect all the terms on the right side of it here. So negative times positive, that will be negative, so negative 75, and then negative times negative here will be positive 45. So when I get to this step, it is similar to the step that I had here. So by simplification, 75 to subtract 75, you'll end up having 0, and then 2 root 45 plus 2 root 45, no, root 45 plus root 45, you end up with 2 root 45 to divide by 2. And the rest of the steps will be as I've captured here. So you end up having our simplification as 3 root 5. Question 4. Simplify this expression. Solution. So in this question, I can decide to consider using the LCM method, where the LCM of these two denominators here will be the multiplication of the two expressions. So I'm going to have root 7 minus root 2 to multiply root 7 plus root 2. If you have this as LCM and you divide by the denominator of the first fraction, it will eliminate the expression that is having a negative. You are left with this one. So this expression here is the one to multiply with 3. So we end up having 3 into root 7 plus root 2. And then if you take again the LCM and divide by this expression here, you are left with the expression having negative, which is going to multiply with 2. So you're going to have here negative 2 into root 7 minus root 2. And then the next step is to open the brackets for the numerator. That will be 3 times root 7, that is 3 root 7, plus 3 multiplied by root 2, that is 3 root 2, and then minus 2 times this, that is minus 2 root 7, and then negative times negative here will simply be positive, so that will be positive 2 root 2. And then on the denominator side, we've agreed that this will lead us to difference of two squares, so I simply take the first term squared here, that is root 7 squared, to subtract root 2 squared. And therefore on the denominator we are going to have, that is simply 7 to subtract 2. And then on the numerator I can decide to consider performing operations for surds of the same order. So I can have 3 root 7 to subtract 2 root 7. That one, something can happen there. And then I can also consider 3 root 2 to add 2 root 2. So for this case, I'll subtract the coefficients. Since these two are of the same order, I end up having 1 root 7, which is simply root 7. And then this other one here, it will be positive 3 plus 2, that is plus 5 root 2, all divided by 7 minus 2, which is 5. And this is the solution. Question 5. Simplify the following. And this is the expression here. Solution. To simplify this expression, I can decide to consider the conjugate of the denominator here. So I'm going to consider this conjugate to be 2 over 3 to subtract root 5 over 3. This is the conjugate of the denominator. So whatever I multiply on the denominator, I should also multiply on the numerator. So on the numerator, the expression there is going to be multiplied with 2 over 3 to subtract root 5 over 3. Okay, now our next step is to expand binomials. So by expansion here, we're going to consider the numerator as 1 to multiply 2 over 3 to subtract root 5 over 3, and then subtract here root 5 over 3, which is this one here, to also multiply the bracket. So 2 over 3 minus root 5 over 3. And then on the denominator side, it will simply be difference of two squares, which I can capture it here. I'm going to have 2 over 3 squared to subtract root 5 over 3 squared. So my next step will be opening the brackets for the numerator. So since I'm multiplying by 1, I'll end up simply having 2 over 3 to subtract root 5 over 3, and then here I'm going to have minus 2 root 5 divided by 9 plus, because negative times negative here will be addition, root 5 times root 5, that will simply be 5, and then 3 multiplied by 3, I'm going to get 9 as my solution. And then the next step is to put like terms together here. So I have the fractions that are not in surd form. I can have, okay, let me capture the denominator first, which will be by opening the bracket with the squared there. I'm going to have 4 over 9 to subtract root 5 squared, which is simply 5 divided by 9. Okay, so my next step is to consider the fractions. I'm going to have 2 over 3 to add 5 over 9, these ones can add together like that, and then to subtract root 5 over 3 minus 2 root 5 over 3. And then on the denominator side, if you divide these two fractions, definitely you're going to end up with the negative 1 over 9. So on addition of these two fractions, I can consider my LCM to be equal to 9, and therefore 9 divided by 3, that is 3 times 2, 6, and then 9 divided by 9 is 1 times 5, that is 5. So 6 plus 5, you end up having 11 over 9. And then when it comes to these other fractions, I think I made a mistake here. It's supposed to be negative 2 root 5 over 9. So this one here will be divided by 9. So again, for that one, the LCM is going to be 9. So 9 divided by 3, which is 3 times negative root 5, you end up having 3 root 5, negative 3 root 5, and then 9 divided by 9, which is 1 times this one, to subtract 2 root 5. And this will be divided by negative 1 over 9. So we'll end up having 11 over 9 to subtract minus 3 minus 2, since we are subtracting the coefficients of surds of the same order here. So you're going to have minus 5 root 5 divided by 9, and then this will be over 1, negative 1 over 9. And therefore, to get rid of the denominator, I can decide to multiply by negative 9, and whatever I multiply on the denominator, I should also multiply on the numerator. So I also multiply here by negative 9. So this will ensure that 9 will cancel there. You're left with negative 1 times negative 1, which is simply 1. So that gets rid of the denominator. And then on the numerator side, if 9 is going to multiply this fraction, since it's negative, I'll be left with the negative 11. And then when negative 9 cancels with this one, I'll be left with negative 1, which when I multiply here, it leads me to a positive. So positive 5 root 5. So this is the solution, which I can simply write by beginning with a positive term here by talking of 5 root 5 to subtract 11. And this is the solution.